Welcome to our tutorial on natural language processing, or NLP, using Java. In this video, we're going to dive deep into the world of NLP, exploring its key concepts and practical applications. First, let's briefly discuss what natural language processing is. NLP is a branch of artificial intelligence that helps computers understand, interpret, and manipulate human language. It's extensively used in applications like chatbots, search engines, and sentiment analysis. Before we begin coding, let's set up our environment. We will be using the Stanford NLP library for this tutorial, which can help us perform various NLP tasks efficiently. Now that we have our dependencies set up, let's write our first program that tokenizes a sentence. Tokenization is a process that breaks down a text into individual words or phrases. When we run this code, it will output each token of the sentence on a new line. This is the foundation of many NLP tasks, such as search queries and data processing. Next, let's move on to another fundamental NLP operation, part-of-speech tagging. POS tagging assigns labels to each word indicating its grammatical role. The output of this code will show each word in the sentence along with its corresponding part of speech, such as noun, verb, or adjective. Another interesting NLP functionality is named entity recognition, or NER, which identifies named entities in the text like people, organizations, and locations. When this program is run, it will display the named entities recognized in the text, along with their types, for example, the name of a person or the name of a location. Another critical aspect of NLP is sentiment analysis. This process involves determining the sentiment or opinion expressed in a piece of text. Here, we just performed a simple keyword-based sentiment analysis. A more sophisticated approach would involve using machine learning techniques. Next, let's explore how to implement a custom tokenizer with Java. By creating our own tokenizer, we can tailor how we split the text based on specific rules. This custom tokenizer uses string tokenizer to define custom delimiters. This can be handy when processing text that does not meet standard spacing rules. Now let's tackle text classification, a process of assigning categories to text based on its content. One common approach is using a machine learning model. The output will classify the input text into predefined categories. For a real-world application, you would want to build a more robust and trained classifier. As we move toward the end of our tutorial, it's essential to highlight how language models such as BERT or GPT enhance NLP tasks. Though they are beyond the basic Java Stanford NLP functionality, you might want to integrate such models using Java APIs. In this case, we are simulating an API call to a language model service, which is increasingly becoming crucial in practical NLP applications. Integrating such models can significantly enhance your text processing capabilities. Now that we've covered the fundamental aspects of NLP in Java, let's recap what we learned today. We started with the basics of tokenization, part-of-speech tagging, and moved on to named entity recognition and sentiment analysis. We also explored how to implement custom tokenizers, basic text classification, and even how to integrate sophisticated language models into our applications. Remember, NLP is a vast field with many libraries and frameworks available. We focused on Stanford NLP for Java, but there are others like Apache OpenNLP and Deep Learning 4J that you should definitely check out. If you have any questions, please drop them in the comments below. If you found this video helpful, consider liking it and subscribing to our channel for more programming tutorials. Thank you for watching. Happy coding, and see you in the next tutorial.